All right, so we're correcting 9-1, day 1 and day 2. Okay, so maybe do split screen, one side your work, one side this video, and correct your homework. Pause it if you need to go over any of them. So number 1, it says identify the vertex, tell whether it's minimum or maximum. Vertex is right here. 1, -3. So therefore it is a minimum because it dips down. Number 2, 3, -1. It's a minimum because it reaches its lowest point at that vertex. Number 3 is a maximum, 1, 5. Number 4, you're supposed to graph it, 3x squared. So because a is 3, it's going to be kind of a narrow or a skinny graph. Number 5, you have a negative value, so it's going to open downward. Negative 2.5x squared is going to be kind of narrow and it's opening downward. You have a small number here, so it's going to be a wide graph, and it's a negative, so it's going to be wide and it opens downward. All right, we want to go widest to narrowest. So number 7, -x squared is the widest, -3x squared is in the middle, and then -5x squared. Number 8, you get -2x squared, 4x squared, and -6x squared. Okay, if the function is positive or negative, that has nothing to do with its width. Positive or negative just tells you if it opens upward or downward. Number 9, 1/3 x squared, x squared, 2x squared. Number 10, 1/6 x squared would be the widest because it's the smallest number, 1/4 x squared, and then 1/2 x squared. Number 11, when you graph this, the graph is just shifted up 1. So it's shifted up 1. And you should make a table for these. Now if you plug 1 in here, if I plug in 2, I would get 2 squared is 4, 4 plus 1 is 5, so I should be able to check that point right there, 2, 5. So you should have a table for each one of these. Number 12, this is the graph of x squared minus 2, it's shifted down 2. Number 13, 2x squared plus 2. You should make sure your graph looks like this. Number 14, you get -1/2 x squared plus 5. So 5 right there is the y-intercept. When I plug in 0, this cancels out, so I'm just left with 5. Number 15, -3x squared minus 4. Number 16, there's the graph of 5x squared minus 10. Notice that they're going by tens here when they graph it, so you might need to scale your graph sometimes to fit it on there. So the y-axis is going by 10, and the x-axis is going by 1. Okay, so that's okay to do if you want to fit something on there. Number 17. It's going to take about 2.2 seconds for this golf ball to hit the pavement. And if I were to graph this, okay, it would be 2.2 is when it hits the ground, and 75 feet is where it starts. So this is the 75 feet. Okay, and this graph right here has nothing to do with the trajectory of this golf ball. It just has to do with time and height. Okay, so don't get those two mixed up. And then number 18 takes about 8 seconds. Okay, so 8 seconds. So it starts at 1,000 feet. Takes 8 seconds to go down there. And this graph, if you notice, this graph is kind of shaped like this. Okay, that's one side of a parabola. Over here there'd be another side, but we don't have negative time wouldn't exist. Okay, then we did I think we did 19 and 20 here. So if not, you can check on them. The domain is all real numbers. The range is y is greater than or equal to -5. Let's actually check and see if we did these. We did, no, we stopped at 18. Okay, so don't have to check number 19.